Okay, in this problem we're going to review, or in this video we're going to review sketching rational graphs. This is problem 7 on the review. We're going to look at these 3 problems. Okay, so the first thing we need to do here is look at some asymptotes. I like to look at the asymptotes first. So we're in that process. We're going to start with 37 right here. 37 is going to go here. The asymptotes, looking at the denominator for vertical, or looking at seeing if it's reduced first. It's reduced as much as possible. So we're going to look at the first asymptote at x equals 0. So at x equals 0, that's the y-axis, is going to be our first asymptote. So we're going to put an asymptote at that value. So we're going to stick an asymptote right here at x equals 0 for 37. We're going to then we're going to look and see if there's any vertical or horizontal or oblique asymptotes. So in this case, the exponents are the same, so there's going to be a horizontal asymptote. So vertical at x equals 0, horizontal. Since the powers are the same, we're going to divide the two lead terms, and the numerator is 2x lead term and the denominator as x, since it's only a thing, so that's going to give us y equals 2 as our horizontal asymptote. So if we're going to do that asymptote at y equals 2, that's going to be right here at 2 units on the y. Alright, now all we need to do is plug in a few values to the function in order to see what happens. So in my, since we have these asymptotes, the function is either going to go like this towards the asymptotes here, it could go through asymptotes here, it could go in here, or in here. So there should be some on the left side and on the right hand side. So what we would do here is try some values, like find a 0. Okay, the easiest point I could think of is trying a 0 of the function. So if we stick a 0 in there, let's say, or if we try to find the 0 in this function, you get 0 equals your numerator, because your denominator is not going to be 0. We can't do that. That's the asymptote. So that's going to give us x equals 3. We add 6 to the other side, divide by 2, we get 3. So that means that the function is crossing at 3 right here. Okay. And we would I'd try a couple other places just to see what would happen here. So I would make myself maybe even a little chart of values. And see what happens if we put 1 or 2 in there. We're doing r of x here. So if we put in 1 in this function, we're going to get -4 on the top, and then x is 1, so we're going to get -4 there at 1. 1, 2, 3, 4. So we're going to go through this point, and we're going to go through that point. So let's put 2 in there and see what happens. 2, that's 4 minus 6. 4 minus 6 is -2 over 2, which is going to be -1. So we're going to go through -1 at 2. So what's going to happen here is this graph is on the right hand side is going to look like this. Approaches the asymptote here, goes through these 3 points, and approaches the asymptote there. Okay, now I would also put in a few points on this side to see what happens. So we're going to do a few points over here. I think it's going to be up here. From my experience, since this is not an even powered one, it's going to actually look like this. So we're going to try -1, -2, and -3 and see what happens on the left hand side of this asymptote. And so if I put in -1 into the function, I'm going to get -8 over -1, -1, -8 over -1, which is going to give me 8. If I put in, so that's 2, 4, 6, 8, so it goes right to there, which is what I thought it might do. -2 is going to give me -10 over -2, -10 over -2, which is going to be +5. So 2, 3, 4, 5. Okay, and you know, looking at this graph, I'm 1, 2, 3, 4, 5, 6 away from the asymptote. 1, 2, 3, 4, 5, 6 away from the asymptote. So I think this has some kind of symmetry around this point. So I'm thinking the next point is going to be 2 away from the asymptote, because that's what I have here. So I'm guessing it's going to be right there at 1, 2, 3, 4. That's going to be -4. So let's try that out. It's going to be negative. We'll put -3 in there, so that's -12 over -3. -12 over -3, which was 4, which is what I said. So our graph is going to approach the asymptote here. It's coming through there and approaching the asymptote there. So this is the graph of that rational function for 37. Okay. 38, we have x plus 2, so x plus 2 over x times x minus 2. So this is 38. So to graph this one, starting with the asymptotes, that's when the vertical ones are going to happen. It's reduced, so the vertical one's going to happen when the denominator is 0. So when x equals 0, or when x minus 2 equals 0. So x equals 2 there. So I have 2 vertical ones. And if we were to look at this, the bottom is really x squared minus 2x. That power is larger than the numerator power. So that means that it's going to have a horizontal asymptote at x or y equals 0. As my horizontal asymptote, since the power in the denominator is larger. Okay, so we're going to graph those asymptotes. So we have vertical at x equals 0, so same one as we had before. We also have one at x equals 2, which is right here. And we have one at y equals 0, so here. So the horizontal asymptote basically tells you if you're in this region here on the right hand side, it's either going to approach there or approach there. The middle section here, it could cross through. I'm not sure. We'll have to look at that. And then this section, we're going to have these two, one of those two things. So we want to try some points in here. Okay, so let's put some values into this now that we have the asymptotes. Let's start with the value of, we'll see what happens here in this section. So let's try a value of 1. So this is x. And in this function we have, let's go back up here, it is h of x. So h of x, we put 1 in there, we get 3 over 1 times -1, so -1, so that's going to be -3 there at 1. So 1, 2, 3, so we have this point. Alright, let's try 2. Well, 2 won't work. Let's try 3 and 4 to see what happens over here. So 3 is going to be 5 over 3 times 1, so that's 3. So that's about 2. It's not. It's 1. It's 1 2/3. So 1 2/3 is going to be right there. All right. 4 is 6 over 4 times 2. 4 times 2 is 8. So that's 3/4 when reduced. So 4 is going to be 3/4. So it looks like this one's going to have, it's going to go like this over here, approaching the asymptotes on both sides like that. Okay, and I'm not sure if this goes up or if it comes down here yet. I would try another point. There's not an integer point here, but we can try something. We can see if we can get it to equal 0, because it has to cross this axis here. It's got to go through it here. It's not, this part is not really a horizontal asymptote. It's horizontal asymptote to the right or left. So if I took my function, if I took my function and set it equal to 0, so that would be the numerator equals 0. That would be x plus 2 equals 0, also x equals -2. So that actually tells me that at -2 we're going to have 0. So 1, 2. So it looks like it crosses right here at -2. So in this function, let's try some other points. So this one actually may be a little U-shaped here. Okay, so we're not sure here what it looks like, but we can take the function itself and evaluate a couple more points. So this is also not in your non-calculator part, so I might actually use a calculator to help me evaluate this. So let's get out my 83, and we're going to plug in some values here, or we're going to put a function in here. So this is going to help me out a little bit. So I'm going to plug the function in here, x plus 2 divided by, so this one's a little bit more difficult, so I'm going to put it in the calculator, x times x minus 2. And I'm going to look at a table of values here. So actually I'm going to just do zoom 6 and see what it looks like. So it looks like there's a little U right here. So this is actually going to have a little U, and then this one's going to come down and just approach over on this side. Now this line is not really in the graph because it's trying to connect it. So we're going to look at those values. Now we can make a table of values by setting up our own little graph here. I'm going to do independent ask here under table set, so that I'm just going to, when I go second table here, it's not going to have any values. I can just put any value I want in there. It's going to evaluate it for the graph. So if I wanted to see what happens over here, I'm thinking that I already evaluated +1, so but I could put in -1, or I'm sorry, I can put in 1.5 to see where it is on the graph, and it says it's -4 something, so it goes down here, -4 something here. So the graph is going to look like this over here. It's approaching this asymptote and goes around like that. So that's what it looks like on the graphing calculator. Now over here, let's go back to the graphing calculator. We can then, if we want to stick in some values like -1, we can put those in. So that's 1 and that's 1/3. We can go -2. That's 0. We can go -3. That's -0.06. We can then go -4. It's -0.08. So what it looks like is it has to approach the asymptote. So what happens is it crosses here, but it stays really close to the asymptote. So we're going to be at 1/3. So looking at the graph, it goes down here really quickly. Oops, a little bit. It crosses here, and then it goes back close to the asymptote. It just approaches 0 over here. It doesn't go back and cross again. This goes up straight, kind of. Okay, let's see if I can do that a little bit better. Okay. So it bends around here like this. So this would be a general graph of that function. All right, let's go to 40. That's x cubed over x squared minus 4. X cubed over x squared minus 4. Okay, so this is 40. So what we have here is we factor the denominator. It's x minus 2 and x plus 2. Oops. X minus 2 and x plus 2. So that means my vertical asymptotes are x equals 2 and x equals -2. That's when these are 0. Okay, so we have two vertical asymptotes. +2 and -2. Okay, we have a horizontal asymptote here. Since this is larger than this one, we would do long division here to find out that horizontal asymptote, x squared minus 4. Oops, we're in a different kind of pen here. X squared minus 4 divided into x cubed. So I find my horizontal asymptote. We do x here. That'd be x squared minus 4. Our x cubed minus 4x. Sorry, got to multiply this times both of those. We subtract, we get 4x. This doesn't go in evenly anymore, so this is my horizontal asymptote, y equals x. So that's going to be a line at 0, 0, crossing through 45 degrees, -1, -2. So start here at -2 and draw your line through there. Okay, and then for the purpose of this, we're going to extend this side out straight out this way. So we have more asymptote. So now let's look at the graphing calculator and see what it says by doing this problem. So clear out last one. We have x cubed divided by, divided by x squared minus 4. And let's look at the graph. This is on the standard mode. So it looks like, see, it's approaching the asymptote here. And then it looks like there's a little piece in the middle, and then there's this other part that's in the asymptote. So let's try some values here. So we're going to go to table. I'm just going to go to auto, which is going to start at 0 and count by 1. This way I have a few values. Okay, and I can scroll up and down to get negatives. Alright, so if we start at like -4, we're going to have, let's move this over. Okay, so -4 is going to be at -5.1, 2, 3, 4, 1, 2, 3, 4, 5. Okay, right about here. Remember, it looks like on the graph it looked like this. Turning and going this way. Okay, at -1, we're at a third. At 0, we're at 0, and we're at -1/3 here. So it looked like this on the graph. It approached the asymptote, goes through these 3 points, and approached the asymptote this way. Not the best graph on this. And then let's go down, see what happens over here. So it looks like the same over here. So 1, 2, 3, we're at 5.4, 5.4, and we're at 5.3 here. So it's going to come down here from the asymptote and turn and go back up like that. Okay, so that's the graph of 40. All right, and so those are those 3 problems in graphing.